Hello students, welcome to short video series of Pravegaa Education. So students, today I am just going to discuss a very important concept about the stationary state. And this concept is actually backbone of quantum mechanics. So let's say what is this particular stationary state. So when you will solve the time dependent Schrodinger wave equation, and the time dependent Schrodinger wave equation is I hat d psi, and this will be a function of xt upon dt is equal to you have h psi xt. So this is your time dependent Schrodinger wave equation, and the solution of this particular time dependent Schrodinger wave equation is psi xt. And when you will write this particular psi xt in as a function of phi x, and you have one phase factor, that is e to the power minus I e t upon h cut. And what is this phi x? This phi x is actually solution of time dependent solution, or it is energy eigenstate. So what you have h phi x is equal to e phi x, and this e is related to energy eigenstate of this particular phi x. So this is your time independent Schrodinger wave equation, and phi x is energy eigenstate. So what will happen? If you have at t is equal to 0, then you have psi x0 is basically phi x, and because we will put t is equal to 0. And what is your psi xt? The psi xt is basically phi x, and there is one phase factor e to the power minus I e t upon h cut. And if you will take the mod value of this, you will take the probability density, then what will happen? Mod psi x0 square must be equal to psi xt square. And this is equal to basically mod phi x square. And if any wave function have this type of property, then it is said to be what? Stationary state. So it is very interesting that every state is not a stationary state. You have to always take care. Only those state which is just going to follow this particular concept, that mod psi x0 square is equal to mod psi xt square, is a stationary state. In general, the energy eigenstate of a Hamiltonian, or the energy eigenstate which is the eigenstate of Hamiltonian, is the stationary state. But if you have a linear combination of two different states with two different energy eigenstate, will not be a stationary state. So this is a very interesting. So if you are talking about a stationary state, you have to take care of energy eigenstate. So you have to just see, suppose I have any state, suppose we have h phi n is equal to En phi n, and h phi m is equal to Em phi m, and suppose we are making any particular state psi xt, that value is equal to Cn phi n e to the power minus I En t upon h cut, plus you have Cm phi m e to the power minus I Em t upon h cut, and here we have En is not equal to En. Then what will happen? Your phi m and phi n is a stationary state, but psi xt is not a stationary state, because you can easily see that mod psi xt square is not equal to mod psi x0 square. So here mod psi xt square is equal to not mod psi x0 square. So you have to always take care of this particular thing. In the examination, they are just asking what will be the stationary state and which will be the not a stationary state. So you have to take care of this thing. So upcoming JAM, in the JAM examination, this type of question can be easily asked for a 1 marks or 2 marks question. Thank you.